So let's go back to figure out what we have learned about dictionaries. Okay. And you will, when you do, read up on dictionaries on different sources, you will see lots of different things you can do. But honestly, you really don't need them. You really have to understand 2-3 basic things about dictionaries. So to create an empty dictionary, you initialize it as with a curly bracket. Now, when you have dictionaries, you have to describe both the key and the value. When you had lists, you keep adding values to it, and it was assigned an index. But in dictionaries, this is not true. In fact, the fact that you can have any keys is a big find. So to add a new value, you need to specify both the key and the value. Okay. Let's have one called actors. So if I have a dictionary of actors, what will be my keys? What makes sense to have a key for actors? Name. Okay, so for example, you can have for key, all right, I am not coming up with a good name, so I'm going to do Tom Hanks. Okay, so what do you want to store for actors? Well, it depends on what you want. If you wanted to store information that has to do with the movies they have, you can have the number of movies. You can have the set of movies that they are in. So the values will depend on what you're trying to store in this dictionary. So, for example, if I wanted to store just the number of movies, I'm going to write some random number here. So generally, when I have a dictionary, I actually make a mental note for myself. What is it that I'm storing here? So I have key is an actor name, and value is number of movies. So you don't really have to create like an append or something for each key. You just can name it. But you cannot really use a key that does not exist. So if I were to create actors and assign this, it basically has only one key. So if I were to retrieve this, that's fine, but any other value will fail. It will say there is no such key. In the same way, you couldn't have a key an index that did not exist. You cannot do the same thing with dictionaries. So when you are really playing with dictionaries, you have to care whether, if you are using a dictionary in a loop, whether the keys that you are going to address exist or not. So that's what we learned to do that was to check if a key exists. You simply ask key in dictionary. Okay, so for example, I can ask Tom Hanks is in actors, which is true. Colin Hanks is not in actors, which is false. So you can do this in different ways, but this is actually the preferred way because, in fact, when I first learned Python, I didn't know this. This is actually an important distinction because this is actually a set comparison. As such, complexity of this operation is actually low. We will talk about that in a second. You can also do this. Given a dictionary, you can write a function called keys that will return the list of all keys in actors And you can actually ask for Tom Hanks in actors' keys. That also will work. But this operation actually has much higher complexity than the previous operation because you are searching for a value in a list, so the complexity of this is actually order of n. So in fact, I have taken many of my graduate students' programs and then deleted like these 4 characters, and their programs ran 100 times faster because we work with very large data sets. So this is in fact the best way to do this. And if you wanted to iterate over all the keys in a list, you can write a for loop. Something like this. So this is generally how we iterate over. So there are actually helper functions. So suppose you wanted to actually write a function that's never going to fail. So for example, if I ask for actors of Tom Hanks, it works because there is a value. But Colin Hanks currently does not have a value. If I wanted to wrap it up so that it never fails, I can give a default value. I say that if the actor exists, return the value in the dictionary. If the actor does not exist, then return some default value. Since they are not in my dictionary, they should be 0. Okay, closed world assumption. So to do that, you can use this function called get. So the get will take a key, and if the key exists, we'll return whatever is stored in the dictionary. If the key does not exist, it will return this default value. So since Tom Hanks exists, it will return the value from dictionary. Whereas for Colin Hanks, it's going to return me 0 because it does not exist. But the nice thing is it actually does not fail. So if you write a program where you don't want it to really fail, you can actually use this one. Okay? So if you want to read a value from dictionary with a default value for unknown keys, you would do dictionary.get key and default value, like this. This is honestly the most that you will ever need. But yes? This one? Right, so it says from actors, get me the value of Tom Hanks, the value that I stored for key Tom Hanks, if the value exists. If the value does not exist, then return me 0, right? So since Tom Hanks exists, it actually gets me 41, but since Colin Hanks doesn't exist, it gets me 0. And a couple of other valuable functions that we have learned was, so you can get all the keys as a list. You can get all the values as a list. You can delete a certain value. You can delete a certain key from the whole dictionary. You can clear the whole dictionary. And I really do not use anything else. Any other questions about dictionaries? What other things you want to know? Things that I may not remember. All right? Question? No. All right. So this is kind of the basics of what we do with dictionaries. The second thing we talked about last time was complexity. Generally, when you talk about complexity, it means that how long your program is going to take. So that has to do with two things. Generally, when we say complexity, we consider time complexity. It is how much time it's going to take. And we look at kind of scales. Sometimes, it's based on how much input you have, but it linearly scales. If you double your input, it's double the time. Sometimes it is not at all relevant to how much input you have, which is the golden standard. That means constant time. Even though you may have more data, you may actually have the same amount. And sometimes things get bad, okay? So bad generally means n squared. So let's remember this one. So from now on, you should start to get used to some of the things that I will talk about. So one of them is called constant time, or order of 1. It just means that it does not depend on how big your list or dictionary are, right? Does not depend on the size of the data, list or dictionary. And constant time is good because even though you work with big data, you still have the same complexity. The second one we learned was linear time, or order of n. It just means that it linearly scales with how much data you have. So twice the size of the data, twice the length of time the program will take. Right? So, of course, it gets a lot worse. So one of the worst things that you will hear is quadratic time. It is n squared. And quadratic time basically generally means that it basically is a squared time, right? So if I double the input size, it is 4 times longer. If I triple it, it's 9 times longer. So it scales larger than your data. And generally, this is where you have some sort of a double loop, right? So this has to do with some sort of double loop. So, twice the data, 4 times slower, for example. Okay? So anytime you write a double loop, there is a quadratic operation. Quadratic operations are very, very, very slow. Can it get worse than quadratic? For sure it can. So it can get a lot worse. There are worse things in life, right? So for example, there's order of n cubed, which is a lot of operations. Actually, you will find there are lots of order of n cubed things. Like matrix multiplication is order of n cubed. And there is no way around that. You know what is n cubed? Is Google's main algorithm, PageRank, that operates on all of the internet, right? On all of the web. Every single page has an ID. It's an n cubed over that. So that takes a long time. Okay? So you must not write n cubed things because Google can write n cubed, but you shouldn't. And they also try very hard to make it faster. So constant time stuff, let's just remember what are constant time stuff. So for example, if you search for value in set, that is constant time. Or key in dictionary is constant time. The reason why that happens is that it is stored in a hash, and it's easy to look up hash. Another thing that is constant time is you append to a list. And you also add a value to a set. These are all extremely fast operations, which is good. Things that are linear time is things like value in list. That is linear time. And generally, some sort of double loop or any variations of that. And we will actually continue to look at when things are n squared. right? So you have an order of n operation that you do n times, that's n squared. And if you remember or want to go back, you can look at how much that changes the runtime by going to the stuff that we did in last class. Okay? So I know this is kind of confusing. Ask me questions right now. No? All right. So when we do a little bit more about problem solving, I'm going to do a little bit more of this. It's going to become very important. Just to let you know, because there were some questions on Piazza, and that brought back to my old days. This is why I dug up my picture of my sad, hair. When I learned programming, we had very limited computers. So we were extremely worried about how much data I'm going to be reading into my program. So nowadays, if you're operating on your machines, how much memory do you have on your laptop? 8 gigabytes? That's crazy, right? By my standards. So it is also important what the complexity of your program is in terms of space. How much stuff do you keep in memory to be able to compute what you're doing? You would hear from your grandparents, they say, I grew up in the war, and, we always eat bread in a certain way. It's like that. I grew up in a time where space was so scarce that I'm always very aware of how much space I'm using. Like in homework 6, if you are reading the whole data, you don't really need all the data to be able to do the homework, right? You only need 2 pieces of information. You need the name of the villain and the set of stories. So generally, whenever I write programs, I don't keep data that I do not need, because sometimes you're actually constrained. So if you're writing an app for your mobile or for a little embedded device, it's going to be very important that you don't have a lot of stuff in memory. So space complexity is also important because A, it will not fit sometimes. B, it will consume more battery power because you are keeping a lot more information in memory. So space complexity is also important, but you're going to be learning a lot more of that in the next class. So don't keep a lot of stuff in memory. Your TAs will tell you things like, why are you reading the whole file? What if the file is huge? And you will say, well, I have an 8 gigabits of memory. I understand that we are all operating in a different world, but beware that becomes very important under different circumstances. Okay, so with all that, let us try to now think about a little bit more advanced uses of dictionaries. So this was a very simple dictionary, but clearly we can do a lot better because we can store any value in a dictionary. So one of the things that I can do is I can store sets of values in a dictionary. So you can have a dictionary where, let's say, key is a name, and value is a set of hobbies for that person. Apparently, this was written when Despicable Me came out, so you have names from Despicable Me. You have Gru, Margot. Well, we can try with that. So, and sometimes you get angry that I use small variable names, so I'm going to type it all out for you. So I have characters, and I'm going to set characters of Gru to be a set of hobbies. So what hobbies does Gru have? So for sure, world domination. And dancing. Right. I have not seen Minions, so I'm going to use the Minions as a simple one. All right, give me one more character. I guess I have Margot. All right, what is Margot's, I guess everybody has dancing. And let's say Margot also wants to do world domination. If you want to see what that looks like, this is what it looks like. All right? Let's write a few pieces of code that takes this and then prints it in a nice way. So I want to print all the characters and their hobbies in a nice way. Okay? So first write a simple for loop. So I'm going to write a for loop for key in characters. Okay? If you wanted to write a for loop that is actually kind of more interesting, you can say for person in characters. I am going to print person. If you want, you can capitalize. It's not needed. Okay. And then I'm going to print characters of person. Okay. So the first one is the name of the person. The second one is the value stored for that person, right? So the value stored for that person is going to be what type? It's going to be a set, right? What if I wanted to actually print the values in a string? So I want to say minion, column, name of things, group, column, name of, and then you see that the values themselves, the keys appear in any order, right? Because there is no ordering to the keys. They are stored as a set. If you wanted to sort by, let's say, alphabetical, I would actually do something like this. So I would say sorted characters.keys. Okay? Beware of this, because sorted will create a list. So if you were to check if something is in it, it's still an order of n operation. But for iterating over, it's fine. Okay? So if I were to do this, it is now sorted alphabetically. So now I want to, for each person, print their name. Then I want to print the list of hobbies in a list. Okay? So I am going to first print the person's name, like this. Now for each hobby, I'm going to print hobby. And if you wanted to really print it nicely, you can do this, and then put a comma after this, and when I'm done, I'm going to print a new line. The point is that there's so much going on in these short pieces of code that it becomes kind of complicated, right? So print the person's name, put a comma. That means continue on the same line. Then for iterate over each hobby, which is a set of hobbies in here, and print this with a comma. And when you are done with the hobbies, print a new line. Assuming that works. Okay. Now, you see that there is a comma at the very end, right? So I have seen many websites, they still have this, because the programmer did not go the extra mile to remove that last comma. You may say, well, this is kind of difficult. Okay. Well, one thing that I can do is I can construct my line as a string, which is much easier. So I can construct my line as first this. Then I am going to add this to my, and I'm going to put a space right here for each hobby. Then I'm just going to print my line, but I'm going to strip the last comma. If you wanted to print the hobbies in sorted order, you can also do the same thing. I believe this will also work. Okay, so here we go. So you just have to be aware of what is in each item that you are accessing, and then you can appropriately write what the program is supposed to be. What if I want to create now the reverse of it? So now this is your challenge. Okay? I'm actually going to give you full 5 minutes. I want to create a new dictionary, hobbies, which will have as key a hobby from characters dictionary. And then as value, it's going to have a set of names. Okay? With that hobby. For example, if I look at dancing, dancing should have the key of Gru, Minion, and Margot. If I have world domination, it should have Gru and Margot. And for floating, I will only have Minion. Okay? Now, assuming that this set is given to you, the characters dictionary, can you write code for me that will construct the opposite dictionary? This is one of the most common operations you will have to do with dictionaries. Given one dictionary, construct a new dictionary by using the values in it. Okay? So, all right, so let's stop here and let's everybody here try this and think about how you will approach it. First, think about how you will approach it, and then try some ideas, and then we will do it together. Okay? Work with me for 5 minutes here. The point is that you want to use this as an example, you can just use KB and C for the hobbies, right? You don't have to talk about the principle that you're trying to figure out. So what is the thing that, the hardest thing to think about when you do this? Where do you get stuck? Come on. Where do you get stuck? All right, so I will guess where you get stuck, but it may not be where you get stuck. That's why you should speak up. So you're trying to figure out how to find all the keys so that you can put them in, right? Yes? Kind of? Maybe? Okay. So when I first create hobbies, there is no key, right? So basically, and I don't want to create keys that have no person in them. So, well, one of the things that I can do is first I can find all the hobbies, and then I find the union of all of the hobbies, which are sets, then create a key for every single one of them. And then I'm going to go and find for each of those hobbies if the person has that hobby or not. So we can try that. This is kind of the first way I can think about how to do it. So I can say first find all hobbies. And I'm going to say all hobbies is an empty set. All is not a keyword, right? And what is the thing that takes a union of a set? What is the operator? Is it plus? Is it and? And is an intersection, right? The one that takes the union is or, which is this. So I can find all the keys. Then I'm going to initialize my hobbies dictionary. So for hobby in all, hobbies of hobby is equal to an empty set. And now I'm going to go through my characters to actually find who has that hobby. So for so you can do this in one of two ways. You can say for name in characters, for hobby in hobbies, if hobby is in characters name, then hobby is that hobby that. So go through every single person and every single hobby that they have, and then for well, actually don't need that one. Why do I need that one? Okay, because I already have all the hobbies, right? So I can just add the person's name to this hobby. And then I can print this. All right, stop trying to save. Right? Doesn't look correct to me. Does it look correct to you? So who has floating? Only minion, but I actually have for floating all the people. In fact, it's all the people for everything. Because for hobby in characters of name, there we go. All right, stop trying to save. Does that make sense? because we were worried that there was no key, so I found all the possible keys. Then I created an empty slot for all of them. Then for every person, I added their name because I already have an empty slot. Of course, you don't have to do it this far. You can actually do it slightly simple. So this is the first run. This is the first time when you do it this way. But you can actually simplify because you don't need any of this stuff. All we care is that when I'm looking at a hobby, if that hobby is the first time I've seen it, I need to create a slot in my hobbies dictionary for it. Then I can add this value. So for example, if this hobby is in hobbies, then I can add this. Otherwise, this is the first time I've seen this hobby. So first I need to create a key that was not there. So, and this time this is going to be a set that has only this name. And the next time I see something, since it's already in there, I'm going to add to it. Now, by the end of this class, you should be very comfortable with taking one dictionary and converting it to another, but don't you worry, there's going to be a whole homework on this kind of stuff. Hey, it's going to be fun, I guarantee you. Dictionaries are so valuable and so complex that they are used all over the place, okay? Because you don't actually have to use a dictionary that only has a value and a set. So you can have a dictionary that have all sorts of different things, right? So for example, you can use a dictionary as a object. So for example, you can have an address, or let's say you can have a house you describe using a dictionary. So for example, you can have an address. Okay, let's put the RPI on the market. 8th Street, Troy, New York, 12180. What do you want to advertise about RPI? Wi-Fi is bad. Wi-Fi available. I'm going to say meh. All right, what else do you want to advertise? Pollution? Sodexo. Food accessibility. This is true. I'm going to just say Sodexo and think that's going to explain it, I think. Okay. What else do you want? Don't have other things to complain about? Tuition. Oh. Too damn high. All right. Well, the point is that if you're putting on things on market, you may have multiple houses, right? This is one house. You can actually put different houses. You can have a house 2, and you can have similar things. In fact, do you notice 110 Street is actually a real building? It's actually the Winslow building down the hill. It actually is the real building that is at that location. So if you were actually developing an application like Zillow, which actually has all these houses, you will actually have multiple houses, but for each one you have different attributes. So you will actually have these kinds of things like addresses. I will probably immediately put DeFazio's address here, but anyway. So you may have many such attributes for each house, and your data set may be a list of such houses. So the idea is that you can use any combinations of lists and dictionaries in your program. So you can have house 1 and house 2. Okay. So now if you had a program like this, you have to be aware of what your data types are to actually print out. So, so if I wanted to print the address of everything in my list, I would actually first have a for loop for each house. Then I may, for example, print house of, like this. If you wanted to go through and print every single key, you could actually say for key in house, print house of key. Okay, and so on and so forth. So the point that I'm trying to make is that once your data types get more complicated, you have to be aware of what they are. But the nice thing is that this is as far as it goes. Now we have learned every single complex data type. So there's dictionaries, lists, and sets. There's not much else, right? But if you wanted to actually take such data and convert it between programs, there is a very nice module called Json that allows you to take something like this and write it into a string and read it from a string also back and forth. So going back to this, okay. So this is my dictionary, right? If I wanted to actually store this dictionary as a string, I can use this module called Json. So Json means JavaScript object notation. And every single system that you are going to use on the web, more or less, is going to use Json. So if you want to then take a dictionary, like characters, convert it to a string, you can use JSON dump s, which means that take this value, dump it as a string, which will not work because sets are not actually supported for JSON. But I bet that this will be supported for JSON. So let's try this one. So JSON.dump s houses. Okay, let's get rid of this. So let's see the distinction here. Okay. So they look the same, but in fact, this is a string that contains everything. And there are some ways that JSON representation is different. For example, it doesn't allow single quotes. Everything is double quotes. So it will take everything and convert it to double quotes. It does. It supports lists, dictionaries. It supports Boolean, but there's an issue. And why is that we care about this? Because in fact, JSON is used in every single system that you use today. So do you remember when we were in lab and we were actually playing with like images from around the world? So we, in fact, were using two separate APIs that I want to go back to, and then you can see how we wrap them up in the module that we gave you. So let's play with two different APIs so that you can see what that means. Okay. So there is an API called nominatum, which will actually take an address in English, and it will convert it to a box of latitude and longitude. Okay. So just to show you what that looks like, I'm going to hopefully try to cut and paste this, which I am not really successful, but let's try. Every time you cut and paste something from a URL, from a PDF, make sure that it actually is correct. Okay. So basically, this is a long URL, so I converted to this. So it has HTTP nominatum. It does sound a little strange, but okay. Then you have search, and then you have to specify a query here. I'm going to make sure that. So basically, it does support a query where you give it as a string. You have to specify what output format it should be. In this case, it will be a JSON. And you have to describe some other things that I don't remember what these were, but at the time we know that they work. Okay. Let's make sure that this actually works. String line 3, position 1. Line 3, position 1. I'm not sure why this is not working. This actually is the kind of thing that you would write and then ask why it's not working, and we don't know. So you basically have a search query. You describe what it is. You can directly write it in here. And then you describe the format and polygon GeoJSON is equal to 1, and address details is equal to 0. Knight likes that one? All right, fine. Okay. So let's go and get whatever this address is actually going to return us. So we've learned how to do that in the first class. So you have a thing called URL lib. So what you need to do is you actually have to open it like a file, and then you have to read it. So you have to read whatever is this one returns. Okay. And in fact, now I have asked this query, and it actually returned me this complex string that basically gives me a place ID, which is the place they have for Troy. It actually has some other additional information, and it does have a value called bounding box, which is in fact this values of latitude and longitude that is the box that surrounds Troy, New York. So if I wanted to just get these ideas, so you will have to notice that the first object that it returns is a list. In this list, the first item is a dictionary. In that dictionary, there is a key called bounding box. Okay? So if I wanted to really access all of that, I need to take this object, which is actually a string, and convert it to a Java object, a Python object, by using JSON module. So I need to actually take the content and load it as a JSON object. Okay. Now, whenever you convert something to actually a Python object, everything is displayed like this. U just means this is a string in Unicode. For your purposes, this does not matter. Okay? So now, this is actually converted, meaning that, in fact, for example, the bounding box is an address. So I can get this one. Okay? So, for example, content was a list. I can get the 0th item. Now I get a dictionary. Then I can get the bounding box. Is it written like this? There we go. So this, in fact, now executed against another source. There's another resource that we used in class that was Panoromio, which is actually from Google. It takes all the Google images, Google Earth images, and then tells you where they are given a box. So you can take a bounding box and then put all of that in there. I wish I could find this. Let's try to find this. This time I'm going to cut and paste from here because that takes forever. All right. So this is the other URL. This actually takes a different website, which is Panoromio, and you can give it a bounding box and tell it to return some images. So you can say return from 0 to 5 images, and it will return you the same thing. So you can do the same exact thing that we have done and see what kind of value this one returns. This one actually now returns you, again, a list of dictionaries in which I can't see what this is, so I need to actually print this value. I know it's annoying. All right, so, oh yes, you're right. Okay, all right. No, you're correct. Okay, that's why it looked the same. All right. So, so now for this one, actually, you get different photos. For each photo, you actually have a URL like this one. Come on. And that is the one we were returning in your function. All right, so let's try to do this. So, so in fact, to see what this is like, I'm going to print it like this. Okay, so you have now I'm losing interest. Let's print all the keys so we can see what that is. All right, so you have count, has more, map, location, and photos. In fact, what we really care is the photos. For each photo, you have actually photo ID, longitude, and photo title, and then a location. Okay. So, all right, this took longer than I thought. But what I was trying to get at is that after you learn dictionaries, you can pretty much use any API that you have on the web. And we've already been using some of them, but there is a lot more that you can do. So Twitter, Facebook, every single one has an API that will return you a JSON object, which you can convert to a Python object, and then from now on should be able to use with whatever we have. Okay, so that was kind of boring, I apologize. But, you know, I'll fix this one up for you. So let's do one final thing, and then I will go from here, okay? So, so the last thing that I'm going to do, we have like roughly 10 minutes, is to go back to the IMDb example and construct two separate dictionaries. One is finding for a given actor what the movies are, and for a given movie who the actors in that movie are. Okay? And I'm going to do them both at the same time. And when we come back on Thursday, I'm going to use this information to actually write some more interesting program. Okay? We are going to play Degrees of Kevin Bacon. Okay? Using this information. We won't have time right now, but we are going to do that. Okay? Do you know Degrees of Kevin Bacon? You can actually Google it now. You can actually go to Google And you can ask for Bacon degree of Tom Hanks. Okay. How do you search for Kevin degree? Okay. So the idea is that you need to find, given a certain person, how they are connected to Kevin Bacon. Okay, the data we have is not as complete as the web, but the idea is that if somebody is in a movie with Kevin Bacon, then they are degree 1. The only person has degree 0 is Kevin Bacon. Okay? And then, if you were not in a movie with Kevin Bacon, but you were in a movie that with a person who was in a movie with Kevin Bacon, then you are in Kevin Bacon 2. Okay? Now, there is a much more geeky version of Kevin Bacon degree. Have you ever heard of the Erdos number? There was a very, very, very famous mathematician called Erdos, and he wrote so many papers with so many people that he became known because lots of people were Erdos 1. But those were all very important, famous mathematicians. And then you basically have people who wrote papers with those people, so they are Erdos number 2. And then it goes. And people actually have gone online and sold their Erdos number. Like, write a paper with me and you will have Erdos plus 1. I'm telling you all of this because we actually had a faculty member who was Erdos number 1, who just retired this year. So Mark Goldberg was Erdos number 1. So it's very, very valuable. Okay, so we are going to write this, but the first thing we have to do is write a program that will help us get there. And then I want you to think, okay, how to use this to find Kevin Bacon degrees. So basically, we are going to have 2 dictionaries. One is going to be actors, which will have key as name and value as set of movies. And the other one is going to be movies, which will have key as movie and value as set of actors in that movie. Okay? And I want to create both of them at the same time by reading my function called, my file called IMDb data. So I'm going to take each line, I'm going to strip it and split it on this. Now I do know that there is a lot of space in between each character. Isn't this the same thing you have to do for your homework? Like, even though after I split, there's still lots of space before or after each value. So I am going to go through every single item, and I'm going to strip the space. And assign it back to the value so that my values are crisp. Okay? So after I have done this, I know that the actor name is the 0th item, and the movie name is the 1st item. Okay? So what I want to do is now add all this information to my 2 dictionaries. One is actors, the other one is movies. Okay? So if actor is an actors, then I've already seen this actor. All I need to do is add the movie to this actor's information. Right? So I've already seen this actor, I just add him or her, the movie to their list of movies. Otherwise, this is the first time I've seen this actor. I'm going to set this to this. Right? All right, not the best typing job, but that's good. Right? So this is the first movie that I have seen, so I'm going to set this like this. And I'm going to do the same thing the other way. If movie in movies, I am going to add this actor to the list set of movies for this set of actors for this movie. Otherwise, this is the first time I'm seeing this movie. I'm going to initialize it to be an empty one. And in fact, I can write a simple while loop to now use this information to find out things about it. Okay, so I am going to ask for a value. Okay, so I'm going to basically, if command is not in, let's say, 1 and 2, I'm going to break from the loop, so I don't need to really do anything else. Otherwise, I'm going to convert this to an int. I guess it doesn't matter. So if you want to find an actor, I'm going to ask for the actor name. So if actor is in actors, for a movie in actors of so I'm going to say print actor % as found, something like that. Else, you can do other things, but I don't have time, so I'm going to just do the second one. If movie, I'm going to ask for a movie name. And if movie in movies, I'm going to say movie found for actor in movies. Actor. All right, this is not as easy to type. Something like this. Okay, so let's save that in the same place as my IMDb data. Nope, that doesn't work. All right, that's good. Okay. Now I'm running this on 200,000 lines. That was pretty fast. Oh, that was funny. Is not in. Okay. It's always a good test to see if your program actually terminates, right? But I guess it did. Okay. If you want to search for a movie, oh, let's write Polar Express, soulless people. And these are the people in it. If you want another one, let's do Apollo 13. I have to say 2 first. Okay, if I enter nothing else, my program ends. So I just wanted to do this just so that you see that doing this kind of program doesn't take a lot of effort. This is kind of not so different than what you're going to do for your homework. And then we are going to start from this one, and then actually do degree of Kevin Bacon the next time around.